Alright, what we're looking at now is range of projectile. So we'll start by drawing a little diagram. If that's our vertical velocity, and that was our horizontal velocity, so we had an initial velocity v, we'll make that 45 degrees because that gives us the maximum range. So these two velocities, vh equals v cos of 45 degrees, vv equals v sine of 45 degrees. By now it should be really solidly ingrained in your head that it's the vertical velocity that determines the flight time. Now we have to remember one of our kinematics equations. Vf equals vi plus at. We know for the time to get to maximum height, we're just looking at that vertical velocity, and at maximum height Vf is going to be 0. We already know Vi for the vertical is V sine 45 degrees, so we can say Vi is going to be equal to At, or V sine 45 degrees divided by G is going to be equal to T. So that gives us our flight time to get up to maximum height. So if we actually want to know the range, we need to double that time. I'm sure you remember that. So we need the horizontal velocity, v cos 45 degrees, times the time, v sine 45 degrees, all over g, times 2. So we just put the 2 at the front. So now we've got the range is equal to 2v squared, all over g, and then we've got cos 45 degrees, sine 45 degrees. Now that's where some students will get a little bit worried because they're going, what am I going to do with that? You could just stick it in your calculator. You could remember that triangle. When you've got a 45 degree triangle, each side is 1 and the hypotenuse is square root of 2. So these 45 degree angles in each corner have a sine of 1 over square root of 2 or a cos of 1 over square root of 2 at 0.70, whatever it is. So you can just write this in as equal to 2 v squared over g 1 over square root of 2 times 1 over square root of 2, and obviously that's going to give you 1 over 2, the 2's are going to cancel, and our range is going to be equal to v squared over g, which is what we wanted to get to.